Hey everybody, it's Mr. Carr again. Today we're looking at 6.3 day 3. It's our last thing we're going to do with our trig. Today's goal is to be using what's called the inverse trig functions. Whenever we do inverse trig, these are the functions that are used to find angles. So regular trig is for finding sides, inverse trig is for finding angles. This is what it looks like. Inverse sine, inverse cosine, and inverse tangent. So those negative ones just tells you inverse. Make sure when you're going on the calculator, you're using the correct buttons. Like on a TI-84, the sine, cosine, tangent buttons, like the inverse ones are right above it. Usually you have to hit second sine, second cosine, second tangent to get to that. So for our purposes here, we're going to make sure to set these up and then use the right buttons. So for example, one, A and B are acute angles in two right triangles. Find the measure of angle A and the angle B to the nearest tenth of a degree. Okay. So in these cases, you just like everything's set up. If ever you get the sine of A is equal to 7 over 10, something like that, you just have to do the calculator at this point because A will equal to the inverse sine of 7 over 10. That's it. So you just automatically take this and turn it into this. So if you have the sine of an angle equals a fraction, then you just turn into the inverse sine. So I plug that in my calculator. You do the inverse sine of 7 over 10, that comes out to 44.4 degrees if we go to the nearest 10th. Okay, same thing over here. If I have cosine B equals 9/13, that means angle B is equal to the inverse cosine of 9/13. So angle B is equal to about 46.2 degrees. Okay, so again, to the approximately equals 2 there. So this is just plugging in your calculator, just like that. So the other part of this is making sure we understand how to how to choose it, I should say. So it's always based on what angle you're looking for. So for this case here, we're looking for this angle. Again, I'm going to do the same process as I did yesterday or the previous lesson. We're going to label our sides. So I start with the right angle. I label my hypotenuse. Run this angle, we're looking at opposite, and that gives me adjacent for that third side. I'm also going to do the same thing as the previous lesson. I'm going to ask what trig ratio I'm going to use if I know this. I know O and H, that's sine. So I'm going to write it this way. So I know I'm going to use sine to set this up. Okay. I don't have an angle letter, so I'm just going to call it this. I'm just going to say the sine of the question mark is equal to opposite divided by hypotenuse. So again, this one I had to choose. If I was looking for this angle here, this is now the adjacent and hypotenuse. So I would have done inverse cosine, okay? Or I would have done cosine to set it up. So from here, my question mark is just going to equal to the inverse sine of 36 over 53. Okay, so I just plug that in my calculator and I get my angle to be about 42.8 degrees. Same thing on the next one. Based on the right angle, we label the hypotenuse. My angle here, I go over here to the opposite, and that leaves this to be adjacent. So since I'm looking for, or since I have the opposite and adjacent, I'm going to set this up with a tangent because it's a TOA scenario. The tangent of my question mark is equal to the opposite divided by the adjacent. Okay, so once I have that set up, my next step is just to do inverse tangent of my fraction. So I plugged in my calculator and I get 13.7 degrees. And that's it. The only other part that you're going to practice with this one is solving right triangles. So that just means you need to find all your missing sides and all your missing angles. Okay. So for example, something like this. One thing I want to point out real quick. Don't forget about the other properties of our right triangles. If you know two sides, okay, and you don't know the angles, you would have to do some inverse trig to find this, except for angle B, because we know that it's 90 degrees. Okay. But the one thing I do want to mention is finding AC. That length there, I shouldn't call it C, I should probably call it B. So that length there, I'm going to highlight this because you can still do Pythagorean theorem. Since we're dealing with right triangles, you would set this up as b squared is equal to 16 squared plus 20 squared. That would be the first step in order to find that length of AC there. In fact, I can even just do this. I'll just call it AC squared. Okay. So that's just something I want to highlight real quick, but everything else is just the trig. So that's it for today. Again, to find our angles, we're using inverse sine. We're doing the same kind of setups, the same steps that we did before, but now we just need to make sure that our calculator is doing inverse and not the regular trig. All right. And that's it for today. Take care, everyone.